Hello everyone, I'm going to present our paper entitled Experiment on Deep Learning Models for COVID-19 Detection from Blood Testings. This paper was written by Vicky Bismandika, Nunung Nurul Komaria, and Adimas Andi Purwita from Bina Nusantara University. Background. COVID-19 is a respiratory disease caused by coronavirus. The coronavirus poses a threat as it is highly infectious. Although it rarely results in death, the symptoms may vary from mild or no symptoms to severe respiratory problem. The best medical equipment to detect COVID-19 is the RT-PCR medical test. However, the known limitations of using RT-PCR equipment are: RT-PCR test is very expensive, how time-consuming for the results to complete. Hospitals in developing countries might become short-handed. Both the equipment and the test require proper handling of the collected RNA sequences by specialized personnel. Solutions. The benefit of using complete blood count or CBC. CBC test is cheaper. The test result is faster to complete. CBC is common in some developing countries and could avoid hospitals becoming short-handed. CBC does not need specialized staff compared to RT-PCR. There are some existing work also conducted the same experiment on detecting the COVID-19 from blood test. First is from Kabitza et al. Dataset used is from San Rafael Hospital, and they use algorithm logistic regressions, naive Bayes, KNN, random forest, and SVM. The result shows that area under the curve ranging from 0.83 to 0.87. The second work is done by Wu et al. By using the dataset from Lanzhou Pulmonary Hospital. The algorithm that they use is random forest. The accuracy is between 0.97 for the cross-validation and 0.96 for the test data. And then the next study is by Soares et al. By using the datasets from Albert Einstein Hospital. They use the algorithm support vector machine, smooth boost, and ensembling. The area under the curve is around 0.86. And then the study by Banerjee et al. They also use the same datasets. Albert Einstein Hospital, they use a more various algorithm, which is random forest, shallow learning, flexible artificial neural network. The area under the curve ranging from 0.80 to 0.86. Provide alternative in detecting COVID-19 by using blood chemical hematochemical values. Use various machine learning algorithms. Our proposed solution is to develop viable deep learning model by using CBC medical datasets, deep learning instead of non-deep learning machine learning algorithms, to compare deep learning and standard machine learning algorithm in using predicting COVID-19. The lack of deep learning research and development using tabular COVID-19 data. Deep learning performs better in large data as infection number continues to increase. Viable AI model. Viable model performance characterized as follows. The area under the curve validation score should be above 0.5. The model can distinguish between true or false using a datasets other than the training datasets. This is the flow that we perform during the model development. We start with collecting the COVID-19 blood test datasets, and then we perform some pre-processing, and then we continue with deep learning classifier model training, and then model testing and evaluations. Is the model viable? Yes. And then the result is better than previous result. Yes. Model analysis, and then end. What happens if the model is not viable? Then we adjust the parameters. This is the data that we used. The CBC datasets gathered online from San Rafael Hospital in Italy, Albert Einstein Hospital in Brazil. From the San Rafael Hospital, we have 1,736 COVID-19 cases with 816 positives and 920 negatives. In Albert Einstein Hospital, we have 5,644 cases of 558 COVID-19 positives, reduced to 599 COVID cases, which consist of 81 positive and 580 negative. And then we also use data from local in Indonesia, Pasar Minggu Hospital, with 1,741 COVID-19 cases. Each CBC dataset is used to train deep learning model using two DNN architectures. The first one is we build custom neural network architecture developed through trial and error. And then the second one, we use TABNET, which is claimed to be efficient in learning tabular data, and used as a secondary architecture in case the custom architectures is undesirable. This is the architecture of our neural network. The input layers and predictors, the hidden layers with using leaky ReLU, dropout layer 0.5, and then hidden layer using also leaky ReLU, dropout layer 0.1, hidden layer leaky ReLU again, and hidden layer with sigmoid functions, and then the last layer is output layer. This architecture is used for the two hospital datasets other than the Albert Einstein Hospital. And then we have increased the dropout layer in here for the Albert Einstein Hospital datasets because the dataset is different and the structures and the number of missing values is different, so we need to adjust a little bit in the dropout layer. Evaluations. For San Rafael and Pasar Minggu Hospital, training data would use 80% of total data. Test data would use 20% of total data. But for the Albert Einstein Hospital, we use 90 versus 10% total data. Each data is used to train 10 deep learning models by shuffling the dataset 10 times. So we repeat the experiment 10 times to make sure that the result is robust, except for San Rafael, which only trained 5 models to copy the process done by Kabitza et al. The finding and analysis. TABNET and custom neural network. The average model area under the curve, score of the custom neural network and TABNET architectures shown in the table. From these three datasets, our custom neural network resulting in the area under curves about 87-88%. And TABNET also similar, 87, and for the Albert Einstein is not quite good because it's lower, it's only 80%. Based on the table, the average area under the curve scores of all models developed are greater than 0.5, and the developed model with the lowest area under the curve scores exceed also 0.5. On average, the developed neural network model trains using each dataset can differentiate COVID-19 positive and COVID-19 negative. Okay, when we see from the literature review, they all using machine learning. When we compare the result with the previous result from the other author, we can see that the machine learning can yield the area under the curve ranging from 0.83 to 0.87, but with deep learning we can increase a little bit, so we can achieve the area under the curve from 0.85 to 0.9. Except for the Albert Einstein Hospital, the machine learning can have 0.87 and deep learning can goes up higher up to 0.90. So this is the most important feature that we found in the blood test data. We found these three resulted from these three datasets from San Rafael, Albert Einstein, and Pasar Minggu, and the rest we found also important in the other two datasets, like mean corpuscular hemoglobin concentration, monocytes, neutrophil, segmented neutrophil, urea, C-reactive protein, and hematocrit. Okay, I think that's it from us. Thank you very much, and this is our conclusions. The author has achieved the aim of developing viable COVID-19 deep learning classifier using CBC data. The deep learning model developed were able to predict patients afflicted with COVID-19 disease using routine blood test result. Even though none of the deep neural network models performance trained using blood tests were on par with RT-PCR in diagnosing COVID, this method of diagnosis still could serve as a cheaper and faster alternative. The DNN-based blood test could also be facilitated by developing countries which faces the problem of equipment and expert shortage to hinder the spread of infections. The recommendations compared to the number of COVID-19 cases worldwide, the datasets used only covered a tiny portion of actual ongoing cases. Therefore, it is advisable to use data that contains more samples. Further DNN tuning and implementations of other deep learning architectures may yield a more favorable performance. And this is the reference. Thank you.